Think about blocking in an experiment. We want the treatment groups to have experimental units that are as similar as possible. In the gasoline experiment, we blocked for size. The large vehicles got fairly similar mileage, which reduced the variance, the differences between their mileages. But we could do something that could make the treatment groups as similar as possible. Each vehicle could use both gasolines separately. A car could drive with gasoline A in the morning and have its mileage calculated, and the same car could drive with gasoline B in the afternoon and have that mileage calculated. We could do this with every car. In this way, every car gets compared to itself. If there were 90 cars available, we do not need to group them by size. All 90 will get gas A and all 90 will get gas B. This means treatment group A has 90 cars and treatment group B has the exact same 90 cars. But randomization must always be included in an experiment, and for good reason. If all 90 cars drove in the morning using gas A, and then a rainstorm hit in the afternoon while all vehicles drove with gas B, the weather would be a lurking variable that could be significant enough to become a confounding variable. It may act to reduce the mileage of gas B. For this reason, we need to cross over. As cars arrive, we could flip a coin. If heads, the car gets gas A in the morning and then crosses over to gas B in the afternoon. If tails, the car gets gas B in the morning and then crosses over to gas A in the afternoon. In randomly assigning this way, about half the cars have gas A in the morning and about half have gas B, and in the afternoon about half have A and half have B. Once all mileages are calculated, each car subtracts mileage B from mileage A. Only the differences are considered. In this way, the variance between cars is eliminated. A high mileage car can get 38.4 miles per gallon with gas A and 37.2 mpgs with gas B. A minus B is 1.2 miles per gallon more for gas A. A large vehicle got 23.5 miles per gallon with A, 22.5 mpg with gas B. This is a 1.0 mpg difference in favor of gas A. All we analyze are the differences per car. Despite these cars having a 15 mile per gallon difference between them, the mileages are relative to each vehicle itself. We have a difference of 1.2 in favor of A from a compact car and a difference of 1.0 in favor of A for a larger car. We eliminated the 15 mile per gallon difference between the two vehicles and only focused on the relative differences of 1.2 and 1.0. This causes the standard deviation to go way down, making it much easier to find a statistically significant difference between the gas types. Thus, a crossover experiment is very much preferred to a completely randomized design, and also preferred over a typical random block design.